For this presentation, we'll examine the basics of the create table statement in SQL. When we want to implement tables using our design, we use the create table statement in SQL. This statement is used to create tables, fields, and integrity constraints. And the syntax is relatively simple. For example, we start with the words create table, followed by the name of the table. The name is of our choosing. We follow that with a set of parentheses, and we end the statement with a semicolon. Inside the parentheses, we list all the pieces of the table we wish to create, including the fields and their corresponding data types, as well as any constraints that we wish to add when we create the table. So let's take a look at an example. Here's a very simple example using the idea of a student table like we'd seen before. Here in this create table statement, the name of the table is student underscore table. We have 5 fields: SSN, name, major, birth date, and credits. And we have one constraint. This constraint is named. It's named PK underscore student. And the constraint says that the primary key of this table will be the SSN field. Now with each field, we have the name of the field and the data type. We'll talk more about the data types in a minute. But note that every field has a name and a data type, and a comma follows each field declaration. When it comes to how we name things, there are certain conventions we should follow. SQL is a standardized language, but every vendor has slight tweaks that they add to it. Names, generally speaking, begin with a letter and must be less than 32 characters, whether they be table names or field names. This is a good convention to follow. We certainly don't want excessively long names, and it helps to adhere to many of the rules that the DBMS vendors enforce. There are also some names that we cannot use because those words may be reserved by the language or by the DBMS. For example, order. We can't create a table called order, so we often create a table called orders or something thereof. When we need multiple words in a name, like we saw with student table, use underscores to separate the multiple words. We cannot use spaces. So let's get back to data types. There are 2 data types in particular for character data. The varchar type is designed to specify variable length character data, such as words, sentences, paragraphs, things that we want to store, but we don't exactly know how big they're going to be for each individual record. In parentheses after the word varchar in the data type specification, we put an integer representing the maximum number of characters to store. We can store less, but the maximum value says this is at most how many we can store. There's also a char or char type. Now the main difference with the varchar type is that the char type is used to store fixed length character data, when we do know exactly how many characters we need to store for a given record. For example, this would be a good choice if we had a field which was going to be storing state abbreviations. We could use the char type with a size of 2, and each individual state abbreviation that we would store would take up exactly 2 characters. When it comes to numeric data types, there are many different types you can use. The most basic type you can use is numeric. A numeric is simply used to store numbers. You have a couple of optional properties you can specify in parentheses following the word numeric. Precision is the number of digits you wish to store. Generally speaking, this is in the range 1 to 65. Scale is the number of digits on the right of the decimal. Now please note, for those of you who may have had Comp Sci 101 or a related course in the past, when we talk about precision, we're often talking about the number of digits on the right of the decimal. Here, we're talking precision as the number of digits we wish to store, and scale as the number of digits on the right of the decimal. In MariaDB/MySQL, numeric and decimal are synonyms, meaning we can use either one interchangeably to represent a numeric field. Int or integer can also be used for whole number data. In the create table statement, we can also specify constraints. Now we're just going to get a glimpse of some basic ones here. There are many different variations we can use. The constraint clause is how we actually use the create table statement to name our integrity constraints. It's often helpful to name integrity constraints because it makes them easier later on if we need to modify or eliminate them. It also helps with error messages when the constraints are violated. The example you see here, constraint pk underscore student primary key SSN, indicates that we're putting a constraint on this table. Specifically, the constraint is the primary key constraint, which field is the primary key. But we're also giving the constraint a name, and that name can be referenced in error messages and if we ever need to modify this particular constraint with an alter table statement. We can also use the constraint keyword to specify foreign keys. And here's an example. Assuming we have a major table out there, the student table would have a foreign key to the major table. And it would be specified such as this inside of the create table. And again, we can name this constraint. And normally constraints are named with a prefix which indicates what type of constraint. PK for primary key, FK for foreign key, CK for check constraints, which we'll talk about perhaps in the future. But here, we'd specify foreign key, and in parentheses, which field is the foreign key, references, and then the table name, and in parentheses, the corresponding field name. We can also specify cascade rules when we implement constraints using a create table statement. For example, here if we had the foreign key we spoke of on the last slide, we could put something like on delete cascade, meaning, that if the major gets eliminated, the student record would get eliminated as well. This cascading idea is often something that we implement, although it's not the only option. There's also an option to set a field null, on delete, or on update for that matter. There's a variety of different variations we can have here, but this is one of the more common ones. If a record is deleted in the reference table, in this case the major table, then delete all linked records in this table. That's the meaning of the word cascade. Some other SQL table commands you may find helpful. Drop table destroys a table. And by destroy, I mean it destroys not only the data, but the structure as well. It's gone once you execute this command. You can think of it as the logical inverse of create table. Truncate table works slightly differently. It does not get rid of the table, it just empties the data out of the table. And of course, describe, which you've used in the past, lists the fields, data types, and some, but not all, constraint information. This is good when you want to learn more about the fields in a given table. Please note that for all of these commands, most importantly for drop table and truncate table, once you execute them, there's no going back. Some final notes. I mentioned create table, drop table. They are immediate. There is no turning back. When you have constraints, please keep in mind it is usually considered good style to name primary key constraints and foreign key constraints. And as I mentioned previously, this allows them to be removed later on or altered without reconstructing the table. There's an alter table command that you can issue to change the structure of a table after you've created it.